Okay, once again, this is another question about angle between planes. Eventually, we want to find the angle between these two planes, alright? One plane is ACD. ACD will be this surface, alright? The surface facing you going up, from the ground level. The other is the horizontal ground. The horizontal ground will be this one, alright? So we want to find the angle between the red plane and the green plane. So once again, we look at what is the common line between the red and the green, alright? The common line will be this CD, alright? This is the line in common to both ACD and the ground level. So what we need to do now is to draw perpendicular lines, alright? To draw a line that is perpendicular and goes all the way to point A, alright? This is the perpendicular line in a triangle. And then we need another perpendicular. But this question is different from the previous one. In the previous question, all the triangles, they are similar. So we know the two green lines, all the triangles, they are congruent. So we know the two green lines, they are the same. But this case is not that much. We know that the triangles, they are not congruent. So this purple line may not be same as the green line, right? But anyway, this is also a right angle for the purple one, alright? So now we need to find tangent theta. Theta is the angle between yellow and green. Alright, this is theta. Alright, so we need to break down the triangles. We have one more piece of information. We know that this is also a right angle. Angle CBD is also a right angle. Okay, and then we have this length. So let's break down the triangle. First, let's find the purple one. The purple one is easier. Alright, we look at this purple length. Alright. And then the blue line is right here. And then we have the other two lines. That would be 8. This is 8, alright? This is 8, and so is this one. And then we have the 15. The 15 will be right here. This is the 15, okay? Alright, so we have the 8 here, the 15 here. That's all, and the right angle. So how do we find the purple line? How do we find the purple line? Well, there are some ways you can do it, right? One is trigonometry. We can use trigonometric ratio. You can find the theta, right? We know that. Well, let me avoid using theta again. This is alpha. On one hand, we know tangent alpha is 15/8. All right. On the other hand, say the purple, let's call it A. All right. We know that A/8 will be sine alpha. Alright. Using this 90 degrees, we obtain the tangent ratio. Tangent alpha will be 15 divided by 8. Using this particular right angle, alright, we can find the sine ratio between A and the number 8. Alright, so we can find A in this way. Alright. The only problem is that this is sine alpha, this is tangent alpha. So we have to try to find the sine alpha from the tangent alpha. Alright. Now, but I will suggest another way to do it. Let me keep this approach so that you can refer to it. Alright, the approach I just said is I obtain tangent alpha equals to 15 divided by 8. Alright. At the same time, I have sine alpha equals to A divided by 8. So using alpha as the bridge, we can find out the value of A. This is method 1. Alright. Or I prefer a method 2 using the idea of area. The area on one hand, the area of the triangle on one hand is half 8 times 15, alright, because of the right angle there. You just base times height. That is the area. On the other hand, the area can be half blue times purple. It is the base times the height. Alright, the purple is A. We don't know the blue one, but the blue one we can find it with Pythagoras Theorem. Alright, let's say what is the blue line? The blue line is 17 using the Pythagoras Theorem, right? So you can multiply to 17. Using the area as the bridge, we can get the length of A. Alright, using the area as the bridge, we can get the length of A. So we have A equals to 120 divided by 17. Alright. So this is A. Now with A, we can look at the red, green, purple triangle. We have the red line here, all right, the green line and the purple line. We don't know what the green line is, right? But fortunately, we don't have to know, because all we need in the right angle triangle is two lines so that we can get the ratio. This is the yellow, this is the 8 in red. This is the 120 divided by 17 in purple. So eventually we have tangent theta equals to 8 divided by 120 over 17. Alright, and the answer goes to 17 divided by 15. So this is the answer. The answer goes to D. Alright. Okay, so that's how we do it, right? Now, two things you have to remember. Number one, how do we locate the angle between the two planes? How do we locate the angle between the two planes, right? First of all, we draw the common line in blue between the two planes. Along the common line, we draw two perpendiculars, one in green, one in purple, along each plane. And the required angle is the angle between the green and the purple. Between the green and the purple, okay? So we need to find the purple line first, all right? Maybe we need to find the green line. Oh, at the end, we don't need the green line, sorry. We just need to find the purple line. I propose two methods we can find the purple line. One is through trigonometric ratio. The second method is through area. All right, so you can have a choice. Which one do you prefer, right? After you have the purple line, you can use the red line 8 and the bottom purple to find the tangent ratio. All right. Okay, so this is the third question in the MC. All right. Today I want to share with you most of the MC questions. So this is the last MC question today. All right. It's a deceptively simple question. It just said that, well, we have a regular tetrahedron, right? The regular tetrahedron, exactly like this one. Sorry, exactly like this one, right? But now I don't know the length of the side. I know that the height is 2. We want to find the volume of the tetrahedron. We want to find the volume. So let's look at a tetrahedron. A tetrahedron goes to something like this, all right? And then there's a dotted line behind it, all right? We don't know the length of the side, so let's call it A, all right? But then we know the height. The height is 2 cm. The height is the vertical line drop from here, all right? That is perpendicular to every point on the ground level. All right, so let's put that in blue. Okay? So this is perpendicular to all of these lines, okay? So in order to find the volume, we need the base area and also the height. Now already got the height equals to 2, so all we need is the base area. So let's look at the base triangle. All right? The base triangle is something like this. It's an equilateral triangle, all right? The red point is somewhere here. All right, the height goes strictly from this point. And the 3 blue lines, they are here. All right. Now, it's a grave mistake to think that the blue line is the middle between the two. That is wrong, all right? The red point is not at the middle of the line, all right? So it depends on how much you know about the feature of the geometry. For those you know that this red point is 1/3 of the way in the blue line, right? If you extend the blue line all the way here, all right, you'll discover that it is a right angle. And also, the red point is like 2-to-1 ratio dividing the blue line, because the red point is what we call the centroid of the diagram. Centroid of this triangle, the red point. All right. Now, if you don't have this information, that's okay, right? You have to, go through more calculation. If you don't know about this, at least by symmetry, this one is a 60-degree angle. So half of it, each of this angle in the black dot will be 30 degrees, all right? Because the triangle on the ground level is a equilateral triangle. It is a regular tetrahedron, all right? So it is an equilateral triangle at the ground level. And like I said, each of this side is A, all right? So let's call the blue line to be B, all right? So we can use the cosine formula. With 30 and 30, we know that the angle at the middle will therefore be 120 degrees. All right, am I right? Yes, 120. So with B and B and A, we can equate B with A. So we have what is the length of B? We have cosine 120 equals to B squared plus B squared minus A squared divided by twice B times B. All right. So after we simplify this equation, we have A equals to root 3 times B. Alright, that's what you get, am I right? Root 3 times B. Okay, cosine 120 is minus 1 over 2. Alright, so we have A equals to root 3 times B. Now, why do we so concerned about the relation between A and B? Because it goes back to the heights. If you look at the diagram here, we have the height equals to 2. And one of the side length is A. And the base is the blue line B. Alright, am I right? If you look at the triangle here, you find this. And the gray line is A. Alright, we have A here. We have B here. We have the height is 2. Alright. So using Pythagoras Theorem, we can find the relation between A, B, and 2. We have B squared plus 4 equals to A squared. Alright. But don't forget that B is A over root 3. So this is A squared over 3 plus 4 is A squared. Alright, so we have A will be square root 6 if I'm not mistaken. Right? A equals to square root 3. This is the triangle on the horizontal ground level. Alright, this triangle is standing upright. They are on two different planes. Alright, this A2 and B triangle will be this one. It's standing upright, while the triangle here is the one on the ground. Alright, can you make the connection between these two triangles? Alright, so the answer is square root 6. Right? Now, once again, if you choose the answer is a square root 6, it's so unlucky, so unfortunate. You spend all the time in the calculation, only, as I said, you answer the wrong question right. The question does not ask for A. What does the question ask for? The question asks for the volume. The volume, therefore, will be 1/3 is the cone, alright? The volume will be 1/3 base area times the height. So what is the base area? The base area will be A times sine 60 degrees and then times 2. That is the base area, isn't it? Because it's an equilateral triangle, so the angle is 2. The angle is 60 degrees. That should be a 1/2. Sorry. The area of the triangle should be a 1/2. Let me put it in another color. Alright, the area of the triangle will be 1/2 A times sine 60 degrees. Okay, it should be like this. Sorry. Okay, so the final volume goes to square root 3. This is our final answer, but not square root 6. Alright, but you know, in an MC, if you lose a little bit, you lose the whole question. So accuracy is very important in the MC question. Alright. So now these are the 4 MC questions regarding three-dimensional problem. These are the harder, difficult questions. These are the more difficult questions in the DSE paper. So go revise all these questions if you miss something. All right, you have to have an understanding of the three-dimensional shape, and you have to break down into triangles in order to do it. Okay, thank you.